Hey everybody, Christian here, and today I'm very excited because we are taking another step into the amazing world of infrastructure automation and DevOps tools with Terraform. We will talk about infrastructure as code and what that actually means, and also how Terraform can work as an automation tool. Of course, I will show you the installation process, and we are doing a quick example project to just get you started and also talk about some real use cases so that you can understand how this tool can fit into your own projects and workflows. So let's go and deploy some infrastructure. But first I want to thank the sponsor of this video, Teleport, which is an open source access proxy to securely manage SSH sessions, web applications, databases, and even Kubernetes clusters. Every login is protected with a two-factor authentication and audit logging to record sessions and log users' actions. And you can install the free community edition completely self-hosted at no cost, so just download and try it out. And suppose you want to use Teleport within your business environment, so in that case they also offer an enterprise version with additional 24/7 support, an Active Directory integration and much more. So just reach out to the Teleport team. Okay, so let's go back to infrastructure as code and why we're actually doing this. Some of you may still remember that in the past managing any server or IT infrastructure was a pretty tough job. I'm talking about these good old times where we had to set up physical servers on our own. You may went on a terminal or logged into an interface and installed and configured the operating system and all the applications you needed, all completely manually. But when you watched some of my recent videos or even live streams here on the channel, you probably know that this has changed a lot in the recent years. So trends like cloud computing, containerization, and also automation, they have entirely changed how we nowadays deploy or configure IT infrastructure. And this is also becoming more and more critical in all IT jobs today, because manually installing and configuring everything, that has become just too time-consuming and expensive for companies. Because IT infrastructure today has become much more an on-demand requirement where things are changing blazing fast. For example, sometimes you just need a server to run and test an application or a release, or work on a specific project where you just need a web server, a database server, and maybe some other resources. And most of the time you don't need that infrastructure to be around forever, so sometimes you just need that for a few hours, maybe a few days or even a few weeks. And once you've finished your test, you may just want to destroy that infrastructure but redeploy the exact same setup on a cloud provider. And now imagine you would have a dedicated team somewhere where you would need to request them to create or manage those resources all manually once you require them. In a time where everything needs to be dynamic, scalable, and high available, maintaining infrastructure entirely manually has become impossible. And that's exactly why we need infrastructure as code. So instead of setting up these resources manually, we just define what we need. And then we use automation tools like Terraform to do the work for us. So knowing how to work with these tools has become a very important skill in IT. And of course, there are many different infrastructure as code tools that do this kind of automation work, and maybe you already have used some of them. But Terraform, the tool that I'm going to show you in this video, is probably one of the best tools for that job you can use in so many different scenarios. So to understand how Terraform works and how this can fit into our automation workflows, let's compare it to another automation tool that most of you guys probably will already know when you watched some of my earlier videos. It's Ansible. Because when I heard about Terraform and infrastructure as code, my first question was, how is it different from Ansible? And don't both tools actually do the same kind of thing? And yeah, Terraform and Ansible have some similarities, as both tools are there to automate the provisioning and configuration of infrastructure. But you can also clearly differentiate them, because they work opposite under the hood and they also solve slightly different tasks. So Terraform is a tool you'd primarily use to provision infrastructure, so it can automate the creation and management process of resources. And the way it works is that you don't tell Terraform precisely what it should do. Instead, you just define what you want. So for example, you can tell Terraform that you need a Kubernetes cluster in your Microsoft Azure cloud with 3 nodes. And all these 3 nodes should have 4 CPU cores, 16 GB of memory, and so on. And now when you execute Terraform, it will first check if it already created such resources, and if not, it can automatically provision them. But it also always matches whenever your current state matches the desired state. So it figures out an action plan of what it should do to achieve that state. it. It's also keeping track of everything it did and the current state of your setup, so it can actually find out what it needs to change. Let's say you use Terraform to provision that Kubernetes cluster with 3 nodes, but later you want to add another one because you need to scale that cluster. So you simply just update your configuration file and change the 3 nodes to 4 nodes, and then Terraform knows exactly how many nodes you have right now and what it should change. We also call this a declarative approach in programming, which means you don't tell a program exactly what it should do, you just tell the program what you need. And then it figures out which commands it needs to execute to achieve that. Now, Ansible is different in that case. In Ansible, you define your instructions specifically in a playbook, and then Ansible follows these instructions step by step. It may check within these instructions if it needs to execute them to make changes, but it always runs through every single instruction. We call this imperative programming, so you tell the program strictly what it should do and in which order it should do that. Ansible also doesn't track which instructions are already executed, so it always goes through the whole playbook every time you execute it. So you might now ask, well, which method is then better? Should I use Ansible or Terraform? And well, that really depends on what you want. Terraform is exceptionally good at provisioning and maintaining infrastructure. For example, if you have a project where you will need a specific infrastructure like a few servers, some applications or certain resources, or you need to provision the multi-cloud environments, multi-tier applications that you want to automate, then Terraform is the tool you should use. But when you want to configure your infrastructure, maybe update all your packages, configure a web server, or change certain entries in a configuration file, or add user accounts, in this case, Ansible probably is better. And of course, nobody really tells you that you should use this or that tool. You can use Terraform to create these resources in the first place and probably update these resources later with Ansible. So you can always combine these tools, but let me show you how Terraform works so you get a better understanding of how you can use that. Okay, so let's come to the fun part and start using Terraform to deploy some infrastructure. And first of all, I want you to go to the official homepage terraform.io, where you can find lots of great documentation, the Terraform registry to find new providers, community support, and also download the CLI tool. And first of all, we need to download Terraform on our workstation to use it. So click on Download CLI, and then you can simply download the executable on all the different operating systems depending on what you're using. So if you watched some of my videos, you probably know that I'm running Windows as my main desktop operating system, but I'm also running the Windows subsystem for Linux with Docker and Docker Desktop to quickly deploy some development environments and use that to test and try out certain things. And if you're not already familiar with Docker, Docker Desktop, or Windows Subsystem for Linux, or you probably want to know how I've set up my development setup, I've made an entire video where I walk you through all the different tools that I'm using and how I've installed and set up them. So just go and watch it. I've put you the link to that video in the description down below. And on Linux, the Windows Subsystem for Linux, for example, you can simply download this executable file here, but you could also just go on an Ubuntu distro, for example, and install Terraform through the apt package manager with sudo apt install Terraform, and that will also install the CLI tool. And then you should be able to execute the command Terraform, and you can see what you can do with this program. So the way Terraform works is you would usually create your project folder first, where you define the specific resources you want Terraform to deploy and on which provider it should deploy them. And then you use the CLI tool inside this project folder to execute that, and Terraform will then provision that infrastructure. And on the official Terraform homepage, you will find some great guides how you can use that. For example, just go to tutorials and find some of the getting started guides on AWS, Microsoft Azure, Google's Cloud. But I'm going to show you the example with Docker because this is very simple. And if you've deployed a Windows Subsystem for Linux with Docker and Docker Desktop, you can easily use that to do your own testings and get started with Terraform very, very easily without using any of these providers here. So I've basically just copied and followed the exact tutorial because it is very good. And I just created a new project folder here. So just go to my resources and go into the Terraform folder where you can find 2 examples I'm going to show you in this video. First, a simple Docker example, and then we also cover a cloud deployment example. And you can also find all these example files on my personal GitHub page in the boilerplates repository, where I show you some configuration templates for various projects like Ansible, Docker Compose, Kubernetes, and now also Terraform. So just go into that folder, and I will constantly try to add more templates and configuration deployments once I've tested and tried them out in my setup. But for this video, you will find all the necessary files in the example folder, and just go in here and copy all the files into your own project folders, and then use that to follow the example. So I already prepared that and created those files into the simple Docker example folder, and let's try to open this in Visual Studio Code. So the way Terraform works, or how you define configuration or resources in Terraform, is you create files with a .tf extension, and inside this project folder, Terraform will always recognize all the different files. But for this simple example, I've just created one file that is called main.tf. And first of all, we always need to define our providers. So to tell Terraform what it should prepare when we initialize this project. So this is the first step you need to do. And you can see in the first resource, Terraform required providers, I've specified the Docker provider, which is using the source Kreuzwerker Docker in that specific version here. So when you want to find out different providers or how to use them, you can also go to the Terraform homepage and go to registry, and then you can browse the different providers. And you can see that there are so many different systems where you can use Terraform. And if you want to find out more details about the Docker provider, then just search for Kreuzwerker and go to Docker. So this provider is there for provision Docker infrastructure. And you cannot just use that in your local Docker environment, so this will be the default. But if you go to the documentation, you can also find how you could use or connect to a different Docker socket. If you, for example, want to manage remote sources or remote Docker servers, you could also do that. But the default is always the local socket. So in my example, I just defined the provider Docker with the default values that will automatically try to connect to your local Docker socket. And then you just define your resources you want Terraform to provision. So we will start with one resource that is a Docker image, and we will set the name to Nginx, and the name of the image will be Nginx latest. So you could also set some optional arguments here. If you want to know what is possible, you just go to the documentation, find the resource you want to deploy, for example, a Docker image, and then it will describe all the different parameters you could set here. For example, the ID, the keep locally, force remove. So in the documentation, you should always find this stuff. So let's go back to our example here. And now we deploy a second resource, which is a Docker container here, and set the name to Nginx. And now we want to use the image docker image.nginx latest. So this is very important to understand because this is a reference to the first object here. And you can also use references in Terraform to reference certain attributes of already existing resources, which is pretty powerful. For example, in this example, we use it for that image, but in the second example, the cloud deployment, I will deploy a new server, and I will use the public IP address as a reference to automatically create a DNS record, which is pretty powerful. I will show you that later. And the name of our resource will be set to tutorial. So this is the name of the Docker container, and we want to expose the internal port 80 to the external port 8000. So as I said in the documentation, you could also add other attributes here and set specific settings here. But first of all, we will go with this very simple example. And before we start deploying those resources, we need to initialize a new Terraform backend. So you can easily do that by going into that project folder and execute Terraform init. So now Terraform will try to find all the required providers you have defined in your Terraform files, and then it will start finding these plugins and downloading them. And once this was successful, you can see Terraform has been successfully initialized. If we go back to the VS Code project, you can see that Terraform has created a new folder .terraform where it stores those provider files that it has downloaded. Okay, so we have now initialized our project, everything is defined, we have defined our resources. Let's start deploying them on my local Docker server. So let's go back to the terminal and type in Terraform apply. So with this command, you tell Terraform to apply all changes you have made in the files, and it will automatically recognize if it already deployed something, and if not, it will create new containers or new resources. You can always scroll up and see what Terraform will do, because Terraform says what it will perform. It will now try to figure out an action plan depending on what you have defined in your resources. And you can see that it automatically figures out its own order of instructions. So you can see it doesn't follow this order here. the action plan will always be dynamic and try to figure out what it needs to change. If you checked everything and you said, okay, this is what I want to do, you can confirm this with yes. And then Terraform will start creating those resources. And if you now execute the Docker PS, you can now see that Terraform has created a new container with the name tutorial and exposed the port 8000 to the internal port 80 of the container. So we now should be able to open the web server on the port 8000. And you can see this is now working. So that is great. If we now go back to the project folder, as I said, Terraform will keep track of all the changes or the current state of your project or your resources. And you can see that it has created a new file that is called terraform.tfstate. So this tfstate file is extremely important, and it stores all the information about your resources, like the container name, the entry point, the IP address, all the resource information it has. And if you now go back to your main files here and try to change something, for example, let's try to expose the port 8081 instead of 8000 here. And now we can go back to Terraform and apply these changes. Terraform will now figure out, okay, so the image was already created. I don't need to create this, but I need to change the port on the Docker container here. So if you're not quite sure what Terraform will do now and you don't want to apply the changes, but you first of all want to check them, you can also execute the command terraform plan. So Terraform will now try to figure out the plan, and it will show you in detail what it would do when you apply this. So let's scroll up and you can see that Terraform says Terraform will perform the following actions. Container engine X must be replaced. So let's scroll down. You can also see what actually will be changed, and you can see that the external port will change from 8000 to 8081. And this forces a replacement. So this is because Docker works the way it works. So if you want to change a port on Docker containers, you would need to destroy that container and redeploy it again. And Terraform is smart enough to recognize that this forces a replacement of the container, that it couldn't simply change the port, it needs to recreate that resource. And therefore it shows you that it will add one new resource and destroy one old resource. So if we now want to do that, we want to apply these changes, simply type in terraform apply. It will check again what it needs to do, and then we need to confirm this. So now it destroyed the old container and it deployed a new one with a different port. You can also see the change here. And if we go to the web server, we now can access the web server on port 8081. And now this is working. Okay, so this is great. This is just a basic example how you can use Terraform to automatically provision infrastructure. So there are two things that I would say are very important if you start testing this, and you will quickly figure out how Terraform works. Because Terraform keeps track of all the resources it has deployed, but you can also see that I'm running more than one Docker container here. I've already deployed some resources outside of Terraform. And Terraform doesn't know these resources. It doesn't keep track of them. So when you start using Terraform to create a resource with a name, for example, that is already existing, Terraform will fail to execute it. It will automatically say that, and it recognizes the error, but it can't create any resources that are already existing with the same name, for example. So this is something you need to consider. And also because it keeps track of all the changes, you might want to change something like the port or the name. And if you now go to a Docker container, for example, and manually change any resources without Terraform, Terraform won't know these changes, and you might run into any issues here, because Terraform expects different values than the resource has. And that also means when you're finished with your project, you would need to terminate that properly. So the life cycle of all these resources should always be managed by Terraform and not outside Terraform. So if you now go somewhere and you destroy the container manually, Terraform won't know this, and it would think that this resource would still exist. And this is why you should always manage the life cycle of all the resources you deployed with Terraform itself, and not outside of the program. So if you now want to destroy your resources or your project, you simply can execute the command terraform destroy. And then Terraform will wipe out every resource in your configuration. You can see that it will destroy those two resources, like the image and also the container here. So let's confirm this, hit yes. And then if we go back to our resource file in the tfstate, you can see that this is now empty. We have destroyed everything. And if we execute a docker ps command, you can also see that the container has gone, the image has gone, everything has been cleaned. So this is a way how you should end or terminate your project. So never go somewhere and just delete the tf state file and go back to your Docker container. Then you would need to delete those resources manually. Okay, so this is great. This is just a quick example, but probably you are now asking, so how could you use Terraform within your project or workflow? So why you should use this? Because deploying containers, you can use different tools to do that. Terraform is not special in this way. But one thing where I find Terraform exceptionally good at is managing cloud resources. For example, if you have a cloud provider and you want to manage resources on Kubernetes clusters or also compute engines. For example, I'm trying out the new cloud provider Civo, where I, by the way, will do a full review on next week. So if you're interested in Kubernetes and cloud deployments, then definitely check that out. It also offers some free credits. It's pretty cool. But in my example here, I just want to show you to deploy a new compute engine with Civo. And I also want to create a DNS record that points to this public IP address of the resource. So now Terraform is very, very powerful in this way because you can also reference object attributes once they have been created or managed by Terraform dynamically. So for example, when I want to create a new resource, I don't know which public IP address this machine will get. It will get an IP address managed by Civo, and that will be dynamically attached to this machine once it has been created. But I, for example, want to create a DNS record that points to this IP address. I can do that with Terraform. So let's go to the second project that is called Cloud Deployment Example. Again, you will find all these files in my GitHub repository, so just go and check that out. And let's open this folder in VS Code as well. And you can now see that I've created 3 TF files here, so not just one, because I try to organize my project most of the time, actually. And in the main.tf file, you can see that I'm requiring 2 providers here. First, the Cloudflare provider and the Civo provider. So let's go back to the Terraform homepage here, and let's search for Cloudflare, for example. So with this provider, you can manage many resources in Cloudflare, which is pretty cool. So you can manage DNS records, you can manage load balancers, IPs, firewall rules, so much with that. So for example, you could also extend this script and deploy a resource, but also automatically add certain firewall rules, or deploy a web application firewall that points to that IP address, or whatever you want to do in Cloudflare, you most of the time can use these providers, which is pretty cool. So now, when you are managing providers that require a form of authentication, remember the Docker provisioner Kreuzwerk that has just connected to our local Docker socket without any authentication at all. But with Cloudflare, we would need to create an API key first, or we need to use our API key and our email address. So in Cloudflare, for example, you need to go to your account settings, and you will find your API tokens in here. And you can also create new API tokens or use the API keys. It's up to you what you use. So in our project folder, you can see that I'm using the Cloudflare email and API key as a variable because I don't want to store the credentials inside the Terraform files. This is something you should always avoid. By the way, also GitHub Copilot is listening to these files, so you never should store any credentials in here. That's why you can also use variables here. And these variables are dynamic. You can also define them in the Terraform CLI once you execute the apply command. But there's also a second way that is pretty comfortable. You can also add a new file, and that needs to have the .auto.tfvars extension. So every variable that you define in a file that is ending with auto.tfvars will automatically load it. I know you could just go here and, for example, just use a Cloudflare email. Just do a Cloudflare email equal and then paste your email address. The same goes for the Cloudflare API key, of course. So this is something I probably won't show you right now. And I also need to add the Civo token. So the Civo token is to deploy my server on my cloud provider Civo. Okay, so let's start taking a look at the resources that I want to deploy. And first of all, let's start with Civo. So let's go to the civo.tf, where you can define your Civo instance, for example. So when you want to deploy a compute engine, that is a simple server with a Linux image, for example, you could go to Civo and could create this manually. But of course, we want to do that with Terraform here. So I want to deploy an instance like this here. Let's go to Terraform and let's search for the Civo provider. And then you can go to the documentation and read about the different resources and things you can do here. So in my example, you can find a boilerplate for a Civo instance here that is called server. And of course, I also want to provision my SSH key automatically so I can directly authenticate to that server here. And the way that works is the provider can also query existing data or existing resources. So for example, the SSH key is something that I already manually deployed on my Civo instance here when I manage my SSH key. So I just created this one, added this SSH key. Then you can query this data. So select data sources and go to Civo SSH key. And then you can find out how you can query this. And you should always place the correct name, which matches the name of your SSH key. So I will just copy this name here, go back to my file and fill in the name of my SSH key. And then I want to create a new resource that is a server. So the server name should be, for example, server.thisrapid.com. And the size is G3 small. So if you want to know the different sizes, you would need to refer to the official documentation of Civo. You can also use the Civo CLI key to find the names, or you can query those specific images by following this example here. And then you can also define several options here. So the disk image should be Ubuntu Focal. This is an Ubuntu 20.04 LTS server. And I also can define some optional values here. For example, some nodes. But in my case, I want to provision this instance with an initial user, and the SSH key identifier is a reference to this object we have queried here. So if you want to reference to existing objects, you always need to query that specific data source here, and then you can use the name of the object here and some of the attributes. So this is something I also want to do for Cloudflare, because then Terraform will start deploying that server here, but I also want to create a new DNS record that points to the public IP address of the Civo instance. And the way how that works is, in the Cloudflare provisioner, I want to create a new resource, a Cloudflare record, which is a DNS record. That is called server. And I first of all need to put in my DNS zone in here, so that is something you can find in your Cloudflare profile when you go to that specific zone. So for example, I select my thisrapid.com staging, and then I can simply copy this zone identifier here. Put it in here, and my DNS name is server.thisrapid.com. Okay, so now the value is the public IP address of my server, and I don't know this IP address yet, but I can reference to the Civo instance with the name server. So remember, in the civo.tf we have put the name server, and then I want to use the public IP address. So why do I know that this is called public IP address? If we go to the documentation of Civo in Terraform, we can see that the Civo instance, so this is a resource, Civo instance, has an attribute in the read-only section which is called public IP address, and then I can simply reference to this IP address the appliance gets. And when you've just configured all your resources, you probably want to test if this plan works. So first of all, remember, I need to initialize a new Terraform project. So let's execute Terraform init. This will now start downloading the providers that I've required in the configuration file. So it's trying to download the Civo and the Cloudflare provider. And once this was successful, I can then apply the configuration. So let's try to do that. I hope that will work the first time. But yeah, you can see that this obviously doesn't work. So usually you always have some issues here. Okay, so this is something I've forgotten. I'm sorry. But it's important that you always, when you define your variables here, you also need to declare them in the configuration file. So just enter variable and then the name of the variable, which is Cloudflare email address. And of course, you don't want to put the value in here. You could do that if you want to define a variable and set a specific value to it. But in my case, I just want to deploy them with no value because I've stored them in the credentials auto.tfr, which will be then loaded into that variable. Okay, so let's add the second one as well. And of course, also for the Civo token. And now we should be able to execute this. Okay, so now you can see that Terraform will start deploying two new resources. The first one will be the Civo server, and the second one will be the Cloudflare record. So let's just try and hope for the best. And now it's creating the server. Let's go to my Civo dashboard here. And now you can see that my instance has been deployed with that specific public IP address here. So let's go to my Cloudflare DNS server. And you can see there is a new entry that's called server with that IP address here. So now, because I've deployed my instance with my SSH key, a public DNS record, we should be able to SSH into that machine. So just type in SSH server.thisrapid.com And you can see this is now working. We are logged into our server. This probably took like a few seconds to deploy this cloud instance. So this is pretty cool. You can see what you can do with that. Terraform is very, very powerful to dynamically provision infrastructure this way. So I will update the GitHub repo and add those variables here for you, and then you should be able to follow this project. Okay guys, so I hope this helped you to understand infrastructure as code and especially Terraform a little more. And you are now excited to use it in some of your projects. For example, I'm currently working on migrating my Kubernetes environment from DigitalOcean to Civo. And using Terraform has already simplified that process so much for me. But there's of course much more to learn about how to maintain the TF state files in a team or share the Terraform project files, for example. Don't worry, I will make more videos about all these topics. And if you want to watch another great video about infrastructure automation and DevOps, I've put you a link to that in the description down below. So check it out. And thanks everybody for watching. I'll catch you in the next one. Bye bye.